Welcome back to the channel, and this video is going to be the hardest one by far, but I'll try my best to break down everything used here. Alright, let's go. Alright, first up obviously is to make the tool. Okay, now that we got our basic script set up, our activator script, also I forgot to turn off our handle prompt. We need to make our hitbox because we want our hitbox to detect when if we're gonna run into something, and it's gonna stop us when we do. So the hitbox is gonna be this big, and I'm making it this big because when we move our hitbox, the position it moves it to is shifting the complete center of our part. And let's just say our hitbox is put this far out from our torso. If there's like this spawn point here, we want it to go over it because it looks stupid if we couldn't get over something, this small thing that we could jump over. So it really depends on preference, but this is how big I'm going. Next part. Alright, the way the mobility thing works is we have our hitbox here, and this checks if the thing in front of us, if the space is open. If it is, it allows the next part of our chest, which basically I move our humanoid into where the hitbox is and then extend our hitbox out. And when it does that, it checks again if there's something ahead of me. So it just does this over and over again until like it reaches the amount of distance I want it to go. Alright, the way we're gonna check if there's an obstruction is through this thing called shapecasting. Shapecasting is raycasting, but it uses a part. And if you don't know what raycasting is, it basically shoots out a hitbox or a thing, and if it collides with something, it will return what it collides. If it does not collide with anything, it doesn't return anything at all. It returns nil. And shapecasting basically allows you to use a big part instead to check if there's a collision. Basically what will happen is, imagine this part is just heading forward. The moment it collides something, it will return an object called the raycast result, and the raycast result will have the position of collision, like where it first made contact, the instance, which is the workspace object that it hit, and a bunch of other things that we don't care about. For the method itself, you need to get your workspace and use the method shapecast on your workspace, and you give in the part which you use for the shapecasting, which is going to be our hitbox, the direction, which I'll explain in the next part after this, and the parameters, which filters out any part that you don't want to be used in the like you don't want to hit with the raycasting. You use this if you want to filter out invisible parts or parts that don't collide with you, because once a raycast hits something, it will return that object and it will end the raycast process, because the purpose of raycasting is to see if there's anything in the way. Anything. Okay, so to explain what the second parameter for the raycast is, it's not an ordinary Vector3, like, oh, it is a Vector3, but it's not like the position Vector3. If you want it to move up, you don't get the Vector3 of the new position it's at. No. What this direction does is, whatever you have here, let's just say we wanted to move it up, what we would do is 0, 5, 0. And what this would do is, it would basically add each of these elements to its corresponding part position in the part position. So in the x position, it's 0, so it won't change the x value. There's 5 in the y value, so it will add 5 to the y value. So 4.8 plus 5 is 9.8, so it will move 5 studs up. And the z value is empty, so it wouldn't move the z value. And that's how basically the Vector3 is asking for. That's what the direction is. So the distance matters too, because a shapecast will disappear after the distance that you specify is over. Alright, so now that I've explained how shapecasting works, it's time for the actual code. And now for the actual code, so we're going to be using the same thing we did last time, or what I showed earlier in the video, is the repeating loop of making shape casting in front of you, then teleporting a little distance, shape casting in front of you, then teleporting a little distance. So first we're gonna make a function for the teleportation, the loop. The reason I'm making it a function, not just putting it directly in our script, is to easily sort out errors and to stay organized. And in case I want to scrap the whole thing, I can just silence it by collapsing this right there, which will make it really easy to silence the whole thing without having to scroll a lot. Also, we need to make our hitbox, which for some reason is not inside of our tool. So when we activate our tool, it will play the dash function, which will activate our hitbox, and our hitbox will move in front of our humanoid, which will be humanoid dot root part character dot root part dot c frame dot look vector times 2.5. If you don't know what this little, basically it gets the distance of the dimensional area. Like, you know how there's an up, down, left, right? Basically the Vector3 is basically if it goes right, then up, then left, the what's called the length of those. And look vector gets the distance of how many of the length of the arrows it takes to get from the first position to the second position, and the second position being the position one stud in front of your object that you're getting the look vector from. Alright, back to the regular video. That means since it's a directional C-frame, like I explained earlier, the number is probably like 0. It's really small, so we have to add it on to the character, the humanoid root part's actual position. So right here we have hitbox at C-frame. It will move the C-frame. First, it will add on the humanoid root part's actual position. Then it will add on the characters that humanoid root parts C-frames look vector. And oh wait, since this is a C-frame, I think I should make this C-frame and put it in front actually. If you add a vector with a C-frame, it turns the vector into the C-frame, because since a Vector3 position is just a part of a C-frame. When you add a Vector3 into a C-frame, it automatically translates into position. If you want to change rotation, you have to do some other special stuff. So now that we have that, I'm going to make our loop. Okay, now what I have written here is first our loop, and it's going to loop 10 times, so it's going to do 10 mini dashes, and it's going to make a shapecast of our hitbox, which should be in front of our character, and it will move, and our direction is the look vector times 2.5. The look vector will always give you a distance of 1 in the direction that the hitbox is, or whatever part you're making the look vector facing. So multiplying by 2.5 will basically give me a direction multiplied by 2.5. So 2.5 studs in that direction, and that's how far we're gonna detect collisions in our shapecast. And you don't need to put in the raycast parameter to make the shapecast work. And if it does not collide with anything, which means it will return nil, that means we can move on to the next one. Since there's still obstruction, we can keep going forward. The move will continue moving. So then we move our character into our hitbox, making it move forward since the hitbox is usually in front of our character. Then our hitbox will again move forward again 2.5 times, getting ahead of our character, and it will keep repeating this over and over until we hit our limit of 10 mini dashes, or until we get an obstruction. if we do get instruction, we need to break out of the loop so it stops. So else, if it returns something, it breaks. So if we test this out, as you can see, it dashes forward, and if we hit our dummy, it stops. So now that we know our hitbox is working, we can move on to our next step of making the after images and all the special effects and stuff. Now for our after images, we're going to be using this function here, which will make it easy to, debug. And since this function will only make one clone one time, because we're going to be putting it inside this loop, which will loop it 10 times for every TP, and that's how we make our after images. And now the after image itself, we're going to be cloning our character model, this right here. However, the problem with cloning our character model is it clones everything inside here, including the scripts. So to fix that, we have this thing called the archivable property, which if you turn off, it will prevent it from being affected by the clone. So if we turn off the archivable function for these scripts, they will not be affected by the clone method. Also, one more thing, the character model, when it's put in here, it will always have its archivable function turned off as it's made, because the game doesn't want us to clone it a lot for some reason. So let's get to scripting. So the first things first is we want to turn on the archivable property for our player model, and then turn off the archivable property for every single script and our tool, because our tool will also be replicated since it briefly enters our character model for a second when we equip it. This here to create successful clone the function so it actually runs. So this right here should create a successful clone, and here we go. Now as you can see, there are two problems that I see here. One, our display name is still here, and two, we can touch our clones, which is bad because we don't want it to make a wall of clones that blocks people's way. To solve the display name problem, all we have to do is get from our clone humanoid or clone character, we get its humanoid, get its display distance type, and set it to string none. This will get rid of the display thing, as you can tell. And to solve our second problem is we're just gonna disable player collisions in general, because games don't usually have player, especially fighting games, and we're making an ability. To disable player collisions, you can't simply turn off the can collide property for all the parts inside of a humanoid. What you have to do is make a collision group and then assign the collision group to every part inside of a humanoid. If you don't know what a collision group is, it is basically a tag you can give to parts, and that will allow it to interact with other parts of collision groups. So I'm gonna make a player collision group, and parts with the player collision group cannot collide with other parts with the player collision group, basically disabling player collisions if every player has the player collision tag. And now we have to make a script that will give every single player that spawns in the player collision tag, so to disable it. So I already have a loop set up here. What this little script does is I put it inside server script service. Now that we've made our collision group, we need to actually use a script to set all the parts of our character to the player collision group. So go to starter player, then open starter character scripts, and put in a regular script here. I already wrote out the script, basically what it does. I can actually explain what this thing does. Any scripts that you put inside starter character scripts will be duplicated onto the character model when it spawns in. So you can see I have disabled player collisions here. When I spawn in, I'll have in my character model right here. Knowing this, we can use it to get our character model, get all the parts, use an iterator to get all the parts, and then set all of the collision groups of every part to player. And this is also really convenient because when we die, it will just remake the script and reset all of our parts to the collision group to player again, which solves a lot of problems. It's really convenient. Now if we test this out, you can walk through our after images. So now we have to make our after images disappear after a short while. However, we don't want the code to stop and wait for the after image to appear one by one. So we're going to be using this thing called coroutine. And I'm not going to fully explain what it does, but basically This line here creates the quarantine. This line here makes the quarantine run because the quarantine has to be made to run. And what a quarantine does, it makes a different thread, and that different thread will run whatever I put inside of this function here, which runs whatever the quarantine is. And a thread is like a script, a simulated script. It will, since it's on this whole script here is one thread. However, when I make this quarantine and start it, it makes a sub thread. And a thread, and what this will do is when I have a wait statement here, since this makes a new thread and runs this wait statement on a different thread, this script's thread, or the script and just the script, will not wait for this thread to run. They will run simultaneously. So if we test this here, my clones will destroy themselves. Onto the final part of our tutorial, we're going to add the effects and touch up with animation, sound effects, and our little effects that we're going to add on the dummy. So we're going to be using the highlight effect, or the highlight object, to make our little grayscale tint effect. And there's a problem with highlights though, just one disclaimer. There's this highlight limit thing, which prevents a bunch of highlights being made, as I'll demonstrate here. As you can see, after certain highlights are made, it will stop creating the highlight object. It will stop functioning. And they do this because of some performance thing, I don't know. So this is not suitable for a game. We're just gonna, if there's like a lot of people using the highlight object, making highlight objects for their ability to work, this will not work because the highlight cap is too low to support so many people using this. So if you want to skip this portion, you can, but I'm gonna make it just in case people want to know how to use it. So first, we're gonna make our highlight object. I'm gonna make two, one for our character and one for the clone people. So we have a grayscale. Gonna make it gray, darken the character, and disable our highlight, and that's gonna be for our clones. This is not gray enough. There we go. And I'm gonna move this highlight under our script here, and then make a second highlight, making off this one. This one's gonna have a red line, white line. I'm gonna put it here, and to differentiate it, I'm gonna name it the player highlight. And now to add them on, I'm going to, since there's the cap, you want to try your best to limit cloning the highlights. However, when it comes to the clone body, it can't be helped. We have to clone it in order to have multiple of it. So we get our highlight for our clone, clone it, and then since the clone thing returns the actual cloned object and makes it at the same time, we can just set the parent of our clone right as we make it to our cloned character, and I'll make a clone, and after that it will destroy itself, so that will limit the amount of highlights being made. And now for the one for our character, we're gonna make a variable for the player highlight because we're gonna move it into our player model and then back under the script once it's done using, or once we're done using it. Now if it does, works perfectly. And now we have to add the animations. I already created a bunch of animations. I think I stored it onto here. I'll show you what they look like. The startup animation right here, which gets the arm back. And the second one is the pose that it maintains while running or while charging. I have it here. I'm gonna duplicate this real quick. Just run now. So the startup is 0.5 seconds, so I have to make a wait statement so the animation actually plays out. And then I'm gonna make the humanoid stand still. for this ability. And for the pose itself, every time I do a little dash, it's gonna make me repose again. And since in the animation, I go back to neutral state, once I stop spam loading, spam playing the pose, it would just make me return back to the neutral state. Or the neutral stance. Oh my god, the studio lag. Okay. And now the only other thing we have to fix is that our clones do not mimic our pose. To make it mimic our pose, we need to anchor every single part of our body when we clone it or on the clone, and it will mimic the pose that we make. To do this, I'm gonna get all the parts inside of our clone and iterate through it and just anchor every single part with an iterator. So when we use this, once this Roblox flag ends, it duplicates our pose, but when we make it run. And now after this, it's just polishing up. I'm just gonna polish this up real quick. It's gonna take a little longer for the after images to disappear. There's gonna be 12 after images. Dashing is a lot faster, 2 times faster. Decrease the cooldown because that thing is annoying. And finally, I'm going to increase the dash distance to 3 studs or 3.5 studs. Changing these numbers, and there we go. We have our dash tool. And now we just got to add our sound, and we're done. Polishing up on polishing up an ability is just trial and error, just changing numbers until it works. I already have our sound here. If you wonder where I got the sound, just go here, go look in the audio section, and just scroll around. Oh, that's my audio. Even though it's really annoying to look for good audio in the toolbox, but a lot of the toolbox noises, especially like the energy sounding ones, you can find them here in the toolbox. It makes it really easy. So once our actual dash starts, we have our little dash. And the dash that I spent like an hour or 2 making for the actual one, as you can see, worked. Also, I completely screwed up. I have to set the humanoid walk speed back to normal once the move ends. Whoops. Don't want our humanoids or don't want our player to be stuck after just using a move. And yeah, that concludes our video. Hope it was helpful. Polishing things is like just takes a lot of time, and level 4 is probably gonna be the most complicated, even more complicated than this one. I'm probably gonna make a bunch of helper videos, short videos, to prepare for the next one, because I don't think I can just briefly explain it. And hope these concepts allow you to make cool abilities. That's the goal here. Alright, see ya guys.